All right, let's look at how you might go about recording bass guitar. Now, in this particular setup, I have plugged in my bass guitar directly to my audio interface. Because I am pretty close to my audio interface, it's right there, I can get away with using a regular old instrument cable to plug in. Doesn't need to be a balanced cable. In fact, a balanced cable probably wouldn't work. But I don't need to use a DI because I'm pretty close. Now, if you're recording more than 15 or 20 feet away, you may need to use a DI to get your instrument to an XLR and get that to your audio interface. You don't want to use a super long, like 50-foot long instrument cable. That's going to present all kinds of problems with noise. You plug your instrument cable into here, into the input, you plug your output via XLR, and that goes directly into your audio interface. But because I'm so close, I can get away with this. Now, not all bass guitars are the same. This is a really nice bass guitar. It's mine, I love it. But it already has a preamp built in. This is what's known as an active bass guitar. Because it has a preamp, it takes a couple of batteries, and this control section down here is different than you'd find on maybe your standard, Fender Jazz bass or something, with just magnetic pickups, a volume and a tone, and maybe a pan pot from going between pickups. The output on here is a lot louder than you'll find on a passive bass. And because it's so much louder, I need to actually press the pad on my audio interface. Now, what the pad button does is, before the signal gets to the preamp, it actually makes it 20 decibels quieter. In this way, I don't send too much to the preamp because the output of this bass is so hot that if I take the pad off and I turn the gain all the way down on the preamp, turn the volume up, watch the preamp right there. That red light that you see is clip. I'm sending so much information that even with the preamp turned all the way down, it's too much and it's clipping, it's going into distortion. That's bad. So I put the pad on there and then I turn the preamp volume up just a little bit. And now I get a nice juicy signal, and it's not so much that it's pushing into distortion. Now, another way that you can record bass guitar is just like we recorded electric guitar. You can use a microphone on your bass amp. I do not prefer this method of recording bass guitar, and here's why. In general, I think bass guitar amplifiers are awful. Reproducing bass frequencies for an amplifier is probably the most difficult thing out of anything that any amplifier will have to do. Mid-range and high frequencies are much easier for an amplifier to produce. Now, making the situation worse is that our ears detect distortion in bass a lot faster than distortion in the higher frequencies. And that distortion creates a lot of other nasty harmonics and makes the bass just awful. Because bass amplifiers are pretty cheap, they are not very accurate, and so they introduce a lot of distortion. And it's not the good kind of distortion. It's not like tube distortion, gritty. It's distortion like nasty, mangled waveforms distortion. And that does not sound good. Now, if you have a real high-end bass amplifier, it may work for you, but in general, recording your 150 watt practice amp is not going to be a super great sound. Now, if that's your only option, go for it, and it's going to be better than nothing. If you ever look at those bass amplifiers and you make the equalization flat so you're not boosting any frequencies or cutting any frequencies, and then you just turn the amplifier up to a reasonable level, you'll probably hear a lot of hiss if it doesn't have a noise gate on it. If you're not hearing hiss, it probably has a noise gate on it and it's just hiding it. And that is an indication that the preamps on those are pretty sloppy. So you're basically recording a lot of extra noise and junk that you don't want to, and that's why I don't like that way. Recording it direct into your audio interface here gives you a lot of options. I mean, you can reamp it later in the computer. You get your nice dry, clean signal, and then you can apply amplification, simulators, and emulators in the computer and make it sound like anything you want. Let's check this out and see what kind of sound we get with this plugged in direct to the audio interface. It's a pretty nice sound. Now, on an active bass, often you will have tone controls that are different than a passive bass. Now, in this particular bass guitar, I have a volume knob, then I have a pan pot, which basically mixes between these two pickups. All the way this way is this pickup, and if I turn it all the way the other way, it's this pickup. And there's a detent in the knob, if you can hear, right there, where it clicks in the center. And that means it's basically equal amounts of both pickups. Now, there's also 3 tone pots on here. And what these do, this is high frequency, mid frequency, and low frequency. And there's a detent in these as well. You can hear that there. So when it hits the click, it's right in the center. Now, when it's right in the center, it's not doing anything. It's not boosting high frequencies, and it's not cutting high frequencies. Now, when you compare this type of setup to a passive bass, and even your regular old electric guitar, the volume knob on electric guitar is not turning it up. When you turn it to 10, it's not up to 10, it's basically doing nothing. As you turn the volume down, it's adding resistance, which also changes the tone of the guitar. As you turn it down, the tone gets duller and kind of thicker, more muddy, or jazzier maybe. The tone works the exact same way on both passive bass guitars and electric guitars. When the tone is up to 10, it's not doing anything. That is whatever the pickups are normally doing. As you turn the tone down, it's adding resistance that only affects the upper registers or the higher frequencies, so it makes it sound like you're basically turning the treble down. And that is, in fact, what you're doing. You're turning the treble down. When it's up all the way on a passive bass, you're not doing anything. It's just letting all of the sound go through. Now, when you're recording instruments like that, a lot of times you might consider just recording it without any of those tone knobs doing anything. So turn your volume up all the way and turn the tone up all the way. A lot of bass players that I've come across when they play live, some of them, especially when they play passive basses, will have their tones kind of cranked down a little bit, because a lot of passive basses are more susceptible to noise because of their shielding on the inside. So by turning down the tone, they kind of get rid of some of that noise or buzz. But when you're recording, oftentimes you'll want those tones in there. And if you're a short distance away from your audio interface, you're not going to get that much noise. So when I record this bass, I leave all of the equalization dials dead center. So it's basically not boosting anything or cutting anything. And I leave the pan pot kind of in the center, depending on the song. I leave the volume knob at whatever's appropriate to give me a good juicy signal with the pad in. If I was recording a passive bass, I would do the same thing. Give the volume all the way up, give the tone all the way up, and then adjust the preamp accordingly. So I get basically everything the bass has to offer. And then if I need to take anything away, I can do that with an EQ plugin in software. If you record something that has the tone down and the volume down a little bit, you're already starting from a position where your sound has less treble and less kind of frequency response than it normally would or could have. So if you have to add something later, you're adding something that's not there. You're trying to make something out of nothing. You don't have a lot of tone and you're trying to boost it back up. That's not a great way to do it. It's much better to start with kind of all your bass or guitar has to offer, and then in the software you can always take away, because taking away frequencies is always a lot cleaner than pushing up something that isn't really there. Hopefully that helps you in your bass recording adventures. All right, let's talk recording acoustic guitars. Now, this guitar is not a very good guitar. In fact, it's pretty terrible. But you can make it sound pretty good by using a good microphone and getting that microphone right up close to the guitar. Now, this particular microphone that I'm using is an MXL 991. It's a very, very inexpensive small diaphragm condenser microphone with a cardioid pickup pattern, but it sounds very good. I use this microphone all the time with video productions where I'm recording people's voices inside, and a shotgun microphone would not work out well for that because you get a lot of nasty reflections. But this microphone sounds great on a lot of sources, not just voice. It'll sound great on acoustic guitar. Now you might be thinking, my acoustic guitar has a pickup in it. Why don't I just plug that in? Well, you definitely could, but it won't sound anything like any acoustic guitar you've ever heard on any recording ever. The type of pickups in most acoustic guitars are a basic piezo pickup. And a piezo pickup is a pickup that sits underneath the saddle, and it's pressure sensitive. It sounds very percussive, very plucky. Works great for live productions, live performances, but for recording, it sounds pretty awful. Now, your guitar pickup also may have a condenser microphone in it, and it may have some kind of system to blend between those. That may sound better, but it's still not going to be anywhere as good as getting a microphone right in front of your sound hole and recording it that way. Now, there are other ways to mic an acoustic guitar using more than one microphone. You could use two microphones and put them in stereo. So you have one microphone be panned all the way to the right, then you have the other microphone panned all the way to the left. Now, some microphones are actually sold in what's called matched pairs, where the frequency response of each microphone is almost identical. You can also use two different microphones, and that'll give you kind of two different tones. As long as you keep them panned all the way right and all the way left, you won't have a problem. Now, when that stereo recording gets dumped down to a mono sound, or when it's played back through a mono system, you could have big problems, because if you're recording the same source on two microphones, you're going to get frequencies that overlap and waves that overlap. Now, waves that overlap that are inverted, so if you have the same wave and it's completely inverted to its neighbor, that wave will completely cancel it out. Now, naturally, that will probably never happen. So it's not like you could set up two microphones, record them both, play them back in a mono system, and the sound would be gone. But you will get some nasty, nasty effects like phasing and comb filtering, where parts of the audio spectrum are completely gone, and it's real nasty. So it's definitely something that you want to keep in mind when you are doing that. There's other microphone techniques that can avoid that, but in general, use the least amount of microphones that you can for recording your source. Or if you want a stereo effect, just record it 2 times using the same microphone and then put each one of those in stereo. The timing differences will probably overcome the frequency overlaps, unless you are a robot, in which case they won't. But that's another good way to do it too. Do 2 separate takes, put those on 2 separate tracks, pan them both right and left, and you'll get a really great response. Now let's check out what this microphone sounds like. Now that sounded pretty great with an inexpensive microphone and a guitar that's in pretty bad shape and is already not a great guitar to start with. Imagine what that would sound like with a great sounding guitar and a great sounding microphone. It would sound fantastic. But it just goes to show you can get some great results even with some modest equipment. Now, how about recording singing or someone speaking doing a voiceover? Well, you definitely could use a dynamic microphone or a small diaphragm condenser, but if you can afford it, a large diaphragm condenser like this one is a great choice. Now, this microphone was not very expensive. It was maybe $300, which is a lot of money, but in comparison to the scope of large diaphragm condenser microphones out there, is on the lower end of the spectrum. And I bought this microphone some 8 years ago, maybe. The microphones available today sound great, and some of them are super inexpensive. I'm sure you can get a large diaphragm condenser for maybe even around $150. It'll sound fantastic for doing voiceovers and singing if you're just starting out. Now, is there a big difference between a microphone that costs $150 and a microphone that costs $2,000? Well, that's for you to decide. There probably is, depending on what you're using it for, but you can definitely get outstanding results using some lesser expensive microphones. Now, if you're recording someone singing or someone doing a voiceover, you may want to experiment with getting the microphone in close, maybe even closer than I am to this microphone, or maybe a little bit farther away. You'll have to figure out how your microphone responds with your talent, or if you're recording yourself, you. One thing that you're definitely going to want to use is a pop screen, which you've seen earlier in this course. That will help take out the air rush that comes out of your mouth when you're saying the plosive consonants, the P's and the B's and all those other ones. That'll really help. Now, when you're recording voice or instruments or what have you, it's good to look at the environment in which you're recording in. And that will help you maybe select the microphone or select where you record in that environment. In general, you probably want to stay away from spaces and areas with large reflective surfaces. A lot of hard walls, especially hard floors, hard ceiling, are not going to help your recording. Now, you probably can't find a whole lot of locations where the ceiling is soft. Now, if you can get some moving blankets or some other type absorption material up on the walls, record in a space that has some nice cushy carpet, that's definitely going to help cut down on reflections and make your recording sound more focused. You don't want to have a recording sounding like it's coming from your bathroom or your shower. So getting some things up on the walls, getting some things around you will definitely help. Now, there are some products available that are made to create kind of a small acoustically treated space behind a microphone. Those can work really well in the right applications. My setup in my office utilizes some cheap moving blankets. Now, moving blankets are made of some pretty weighty cotton or other material, and it's a good, inexpensive way to cover a lot of space for not very much money. If you're to look at acoustic foam tiling, those can definitely work great, but the cost per square foot is much, much higher. I like these moving blankets because I can tie them to light stands or background support stands. I can nail them up on the wall. You can also use it to cut down any localized sounds. Like down here, I have my computer living in a little cubby that's surrounded by a doubled up moving blanket. Now, you don't want to wrap your computer in a moving blanket because that'll cause it to overheat, and that would be very, very bad. But I've done measurements in here, and putting my computer in the little cocoon gets it down 3 decibels, which is not huge, but it's definitely noticeable. So moving blankets or acoustic foam is a great way to help kind of treat your space and make it sound a lot better.